Hi class, today we're gonna talk about multiplicative regression, and the question arises in this session for HAP 819 class. Multiplicative regression is a form of regression analysis in which the relationship between the independent variables and the dependent variable is represented by a product of terms rather than a linear sum. This type of model is useful for understanding interaction between variables and can be more appropriate than additive models when changes in one variable are associated with proportional changes in another. The key points are useful for modeling nonlinear interactive processes. Each variable is considered to amplify or diminish the effect of the others. Interpretation of coefficients in terms of ratios or percentage changes. Application that the multiplicative regression are used in health science is for dose response relationships and risk assessment. The question in this session is estimate mortality rate in 6 months for lung cancer patients with various common comorbidities. The instruction we follow is use lasso logistic regression to identify comorbidities that are predictive of survival in 6 months. For comorbidities that make prognosis of lung cancer worse, that is non-zero comorbidities in the regression, identify impact of the comorbidity alone by itself without any other comorbidities. Report the number of such cases and the probability of mortality within 6 months. Fit a multiplicative model to the data and estimate the parameters of the model. Estimate the overall K parameters for the multiplicative model. Let's look at the chart which simplify and visualize the structure we will follow. In data part, we have load libraries, load data, and data overview. The next part is a lasso regression. We have setting up lasso regression, fitting the lasso model, and then model refinements and variable selection. The next part is a multiplicative model which have data frame initialization, data stratification, and statistical calculation, and data frame update. And the last part is estimate over K, which have determined the K value. We're following the steps to answer the questions. Step 1 is load libraries and load data. In this step, we load in the necessary libraries for our analysis. Reader is for reading CBS files, Glumnet is for lasso regression, and tdverse is a collection of our package designed for the data science. We're loading our dataset from CBS files and printed it to view its structure. The dataset containing lung cancer comorbidity data is loaded from a CBS file into a data frame DF. Step 2 is data overview. This line provides a summary of a data frame DF, which is useful for identifying missing values, outliers, and understanding the general structure of the data. Step 3 is setting up lasso regression. Pre-press the data for lasso regression by removing irrelevant columns, ID and survival. The dead column is the response variable as Y, and the remaining columns are predictor variables converted to matrix X. Step 4 is fitting the lasso model. In this step, initialize the parameters to fit the lasso model using cross-validation to find the best regularization parameters lambda. The loop continues until it finds a model that selects a target number of predictor variables. Step 5 is model refinement and variable selection. This part refines the model by adjusting the alpha value and selecting the best lambda that yields the desired number of non-zero coefficients representing significant variables. The results are shown on console part after the line print non-zero coefficient names. Step 6 is impact of comorbidities. This step first filters the main data frame to keep only significant variables identified by the lasso model. Then variables with negative coefficients in a lasso model, the values are recorded 1 to 0 and 0 to 1 in the main analysis data frame. Step 7 is define comorbidity columns. This part lists the comorbidities that will be analyzed in the multiplicative model. Step 8 is a data frame initialization of multiplicative model. The data frame, called df-intercept, is structured to hold the resulting statistics from the multiplicative model, including the name of each comorbidity, the number of cases and controls, the probability of death for each, the calculated intercepts, the overlap of comorbidity among the cases, and the number of cases matched to each comorbidity. Step 9 is data stratification of multiplicative model. A loop starts iterating over each comorbidity. For each iteration, a copy of main analysis data frame is made, and a new strata column is created. This column uniquely identifies each subgroup of patients based on the combination of comorbidity they have, excluding the current comorbidity being processed. Step 9 is a statistical calculation of multiplicative model. Within the loop, the data is grouped by these strata to calculate the number of cases and control, as well as the number of deaths within each group. This information is then used to calculate the probability of death for both cases and controls. These probabilities are joined to estimate an intercept for each comorbidity. Additionally, the overlap of cases across comorbidities is calculated. Step 11 is the data frame update of multiplicative model. After calculating the intercept and overlap for each comorbidity, these new statistics are added to the df-intercepts data frame as a new row, enriching it with detailed information for each comorbidity analysis. Step 12 is estimate overall K. This part defines a range of possible K values and joins this with the intercept data. It applies a criterion formula and filters for K values that fit a specific range to identify the overall K. Step 13 is determine K value. Finally, the code selects the overall K based on the filter values, prioritizing the most extreme values or randomly selecting if no extreme values are present. In a console part, we can see the overall K value is 0, 1. The result of the codes for using loss of regression to identify comorbidities that are predictive of serial limit to around 10 comorbidities of cancer is printed as non-zero coefficient, as we can see there. The other result is the estimate the parameters of the model for the multiplicative model, as we can see the result here. And the last result, the estimate over K parameters, as over K is 0, 1, as we saw on the prior slides. Thank you for your attention.